Hello all, I'm Rishabh Maurya and I'm going to present on the assignment 2 for the course materials characterization. We were given three molecules, three compounds, and the first one is SCT1. So how to start with? We were given two files, INS file and SQL file. INS file contains space group information, cell parameters of the crystal, and SQL file contains all the reflections, that are all the reflections with intensities. So by using this, we opened it on the software called OLEX to on that with the help of electron density, and by using the direct method we solve the structure. So to start for this, we started with direct method, and for this we started with the option known as solve. So there we used the option called program to have the electron density from there. And from the electron density we have to guess the model. What is the actual model? Means our proposed one. We have to assume something. So based on our assumption, we have to proceed. And after giving a particular structure from the electron density, we have to check the refinement. And for this we have to start with the initial electron density, which are of higher ones. Means we have to start with the higher electron density first. For example, what does higher electron density means? Higher electron density means the non-hydrogen atom ones like oxygen, chlorine, and obviously carbon. So we have to start with this. So after giving assignment to the highest electron density one or the highest electron density one, we have to refine it by cell axle. I have started with the number of cycles, which is 8, and I have refined it. And after refinement I have to also check UISO, that is iso displacement parameter. And then after after each after giving each structure I have to refine once again. So I have to keep refining until R factor comes out to be very less. Initially it was more than 10, right? Or to be very specific, in starting it was not applicable. R factor was saying that nothing, no values is applicable. But once I started doing, it showed 10, then it showed 7.3 something. Then after solving all each and everything, it was around 3.78. Then again I refined it, it was around 3.56. So more less is the value. So the the f observed or and f calculated both are in good agreement with each other. Means our proposed uh, model or proposed molecule is having exactly same, which is the actual molecule is, right? The experimental and the calculation method is almost same. So after this assigning, we have to refine it. Okay. And we have to also check the R min R max values. So we have two values. R max value means there is value called 0.3. For example, it is plus 0.3. Okay, it means it accounts for the uncounted electron peak. And also there is a R min, which accounts for the over counted electron peak during the calculation or maybe from the data, right? And this is due to the fact that we have considered the model as fully spherical electron density model. We have not considered the bonding part as well, right? So, and also this is also, we can call it as the difference in the electron density after having all the refinement, after having all the proposal of the model, right? So after having all the things, we made the report. How report was made? We click on the actor, and after this, the after that we got the zip file. And zip file is the basis for each and every calculation or any any analysis for the further in the molecule for further, like here we have, here we are, here there is data for HCT1. The identification code is HCT1, and we have determined the molecular formula of the molecule is C7H8 Cl2O4H2 with the formula weight of 297.744, and crystal system is monoclinic. Space group is P21, right? And here are the lattice parameters are given, right? And since the crystal system is monoclinic, we are having alpha beta gamma value that is 90 degree, and the third one is around 111 degree. Then further index ranging, reflection collected, and also the X-ray values are also given. Which type of X-ray is used? Like for our case, we have used molybdenum, and this is given over here. And also we can see that the flag parameter is around 0.20, which is too good, right? 0.20 means it is close to 0. So our assigned structure or the assigned structure is correct. Okay, there is no enantiomer. Further, we are having bond parameters over here, and we can see this is our structure. We are having a benzene ring, and next to this there is again ring having two nitrogens, sulfur group connected with oxygen, and the benzene ring having Cl, and also it is substituted with S double bond O double bond O NH2 group, right? And here are the bond length and bond parameters are given for the molecule. As we can see over here, the sulfur chlorine bond distance is 1.74 angstrom, and it goes on like this, right? And also here is the chart for the bond angle as well. What are the actual bond angles? Further, we are having the crystal packing diagram. We can see this is how the mot this is how in the unit cell the motif is arranged. So this is the motif, the isometric unit. So how it is arranged in the crystal, we can see over here, right? And this is the simulated PXRD diagram based on the zip file, and we have done this on the software Vesta, right? The very famous and good one, Vesta. So this is the crystal packing structure, and this is corresponding simulated PXRD diagram. In the similar manner, we also calculate for the next molecule, that is ROPA. This is the molecular formula, empirical formula calculated after setting the structure. Crystal system is still monoclinic. Space group is P21 by C. This is the lattice parameters, bond angles. Okay, and we can see over here that this is the actual structure of the molecule. The benzene ring and the sulfur atom, nitrogen atom, that ring contains heteroatoms, and also there is an H2 substitution over here. We can see over here that benzene has substitution of OCF3, and we can see that this this elliptical polarized, this elliptical sphere is so much unsymmetrical due to fluorine electron density, right? And these are the bond and these are the bond parameters, that bond angle we can given over here. Further, this is the crystal packing diagram for the unit cell, right? Crystal packing diagram for the unit cell. This is how in the monoclinic unit cell the motifs are arranged, and this is the corresponding simulated PXRD diagram. Further, for the third molecule, same, it is same. The empirical formula is this. Molecular weight is given. Crystal system is still monoclinic. The space group is P21 by C. These are the lattice parameters, and each and everything same. The radiation is again the molybdenum one. It is 0.71 angstrom. Further, this is the structure of the molecule having benzene ring connected OCF3 group, that is, and then next to it there is a ring having NH sulfur connected over here and NH2 substitution, right? And this electron density has actually C double bond O CH2 C double bond. This is a molecule uh, which is having itself a hydrogen bonding, right? And these are the bond length and bond length is shown over here. This is the corresponding crystal packing diagram, how motifs are written in the central, and this is the corresponding PXRD diagram. And the second part of the assignment contains determination of crystallographic point group for the given crystal. We were given a crystal and we had to diagram. We have to define and find out the what is the crystallographic point group of the given crystal. Actually, after analyzing the crystal, we found that it contains two perpendicular mirror that we can see over here, this one and this one, right? And a two-fold axis perpendicular to these mirror, right? Perpendicular to this mirror. So this is the top view, right? So this two-fold axis is actually passing through this one, right? So our crystal contains two-fold axis, two perpendicular mirrors, hence the point group is MM2. MM2 is centrosymmetric point group, and our crystal is also centrosymmetric, and hence the crystal system is overall orthorhombic. Thank you for this.